Alright, so for today's video, we are going to discuss the very last part of our chapter 1. Okay, so when we are having the normal distribution as an approximation to the Poisson distribution. Okay, so maybe in the previous week or the previous video, alright, we actually already learned how to change a Poisson become from binomial, right? So that means originally you are having binomial distribution and you change it become Poisson. Okay, so the mean is n times p. So of course, when you want to change binomial become Poisson, there are some conditions that you need to fulfill. Okay, so I hope that you still remember about that. Okay, then for today, we're going to discuss another type of approximation. So that means how are you going to change the Poisson become normal distribution? Okay, use the normal distribution with continuity correction as approximation to the Poisson where appropriate. Okay, so again, when you want to change Poisson become normal distribution, generally you of course need to still follow the rules or maybe must fulfill the condition that they set or maybe that you need to have. All right. Okay, so as a condition, this is very, very simple. When you want to have the when you want to change the Poisson become normal distribution, there's only one condition here, which is your lambda greater than 15. Okay, once you see the value of lambda is greater than 15, generally you can change your Poisson from lambda, okay, become the normal distribution. Okay, so for normal distribution, right? Okay, so first value should be the mean. What is the mean for Poisson? Lambda. What is the variance for Poisson? Also lambda. So when you change Poisson to normal, right? Both mean and also the variance are the same, which is lambda. Okay, so when can you change it? It is only when the lambda is more than 15. Okay, and then if we look further, when you're having Poisson and normal, okay, Poisson belongs to a special type of discrete random variable, and normal is under continuous random variable. Therefore, when you want to change Poisson become normal, actually you need to do the continuity correction. So the continuity correction will be plus and minus 0.5. Okay, so that will be what you need to know, okay, for an overall idea. Okay, so let us have a look. Okay, so what do we have in our notes here? So they talk about the continuity correction. Again, as what I said, for me, I didn't use all the formula here because it is very hard for us to memorize. So later when you want to do the continuity correction, I will show you a few examples so that you know how we do it. All right. So for those who are with me since last semester, in semester 1, if let's say you take statistics with me, then you should know the method that I'm using. Okay, for me, I generally didn't use all the formula here because to me it's very hard to read to memorize. Okay, right. So let's have a look for example 16. Okay, so for example 16, first they give you this. So again, as before, this kind of question will not be asked in the exam because it is mainly for understanding purpose. Okay, so let's start. X is Poisson distributed, right, with mean 30. So the mean is large enough, 30, already more than 15, correct or not? Therefore, you can change it become normal distribution. So what is the mean? It is 30. What is the variance? It is still 30. Because of Poisson, both mean and variance are the same. All right, have the same value. Therefore, both of them are 30 here. Okay, then now, for part number 1, they want you to calculate the probability for x smaller equals to 31. Okay, first step, you have to do the continuity correction. So what is the continuity correction here? Should it be 30.5 or should it be 31.5? Okay, so usually for me, I will try to imagine that in my mind there's a graph something like this. Okay, so I maybe take any value close to 31. So maybe I will start with 30, 31, 32, 33, 34, and so on. Okay, maybe 29 also. All right, so if I look at the sign here, x smaller equal to 31. So x smaller equals to 31 means that the 31 is included. Therefore, the probability that I want to calculate is on the left-hand side, include 31. Okay, so when I want to do the continuity correction, what I did is like the value that I take must cover, okay, must be more than or must cover the whole area that I want to find. So that means your continuity correction value should be here. If you look at the graph, it is between 31 until 32. Therefore, you should have x smaller than 31.5. Okay, so of course in exam you don't need to sketch this graph out, like it's just for you to imagine, right? To let you have the idea how we actually do the continuity correction. Okay, all right. So after it is smaller than 31.5, okay, so this is a normal distribution now. Therefore, you have to change it to become Z. How to change it become Z? You standardize it because now it is normal distribution, right? So you take 31.5 minus the mean divided by standard deviation. Okay, and after that, you try to get the value. So Z is smaller than 0.274. Okay, and then just right away get the value from the table. All right, so you use the table yourself to find out. So eventually you should get 0.608, okay, from the table. Right, so you can keep your answer in 3 significant figure, or for this normal table you can put it in 4 decimal places also can, no problem. All right, so just extra information here. When you try to calculate the value of Z, you should get it under 3 decimal places. Okay, because when you get the value right from the normal distribution table, when you want to get a probability from the normal distribution table, generally you will be, how to say, you are allowed, or maybe you can find the answer, okay, for the Z by looking at the Z. The answer, the value given is under 3 decimal places. All right, so to get the most accurate answer, this Z must write it in 3 decimal places before you find out the value from the normal table. Okay, so this is what you have for part A. All right, so maybe you can have a look for part number B. Okay, so again for part number B, they want you to calculate the probability for 35 until 40. All right, so how to get the value from 35 until 40? So again, before I try to get the value right, so I try to imagine a few values here. So maybe I'm having 33, 34, 35, 36, 7, 8, 39, 40. Okay, maybe I write 41 also. Okay, so when they say 35 until 40, so this symbol, does it include 35 or not? No equal sign, that is not included. 35 is not included. Therefore, the value that you start is from 36, not 35, because of no equal sign. And then 40 until 40, is the 40 included or not? So you see, there's an equal sign here, therefore 40 is included. So that means the area that you want to find out the probability is this area. Okay, so to do the continuity correction, you need to have the value that cover the area that you want to find. So the value that you should take off, which is 35.5, and also this one. What is this value? It should be 40.5. So when you write it out, it will become something like this: the probability of 35.5, and then x, and then 40.5. Okay, so this is what you will get. And after that, to calculate the probability, change it become Z. So 35.5 minus the mean. So what is the mean again? 30 divided by standard deviation, which is also square root 30, then Z. Okay, then the same thing applies here. All right. Okay, then if you get the value, it should be 1.004, and then Z, and then 1.917. Okay, so to calculate this probability, it should be Z smaller than 1.917 minus Z smaller than 1.004. Of course, this is not the only method. You can use other method that you understand better, okay, to calculate this probability, Z between two values, right? Then, okay, if you didn't do any careless mistake, right? For me, I'll get 9723 minus 8422. And after that, I'll get the answer 0.130. Okay, so this is the answer that I get. So all the detail, how to find the value from the normal distribution table, you go and figure out yourself because you already learned all this before, right? So if you already forget, take this chance, okay, refer back to the statistic one again and then try again slowly. All right, so all this I'm not going to discuss it again in detail. All right, so make it as a revision for your own also. Okay, so the answer should be 1.1301. All right, okay, then for the part number C. Okay, part number C, how should you do it? They want you to calculate the probability for what? For x equals to 30. All right, so x equals to 30 is for Poisson, but now you want to change it become normal distribution, right? Originally it's Poisson. When you want to change it become normal distribution, you cannot tell me that it's zero, because for normal distribution, equal sign is always a zero one. X equals to a particular value or always equals to zero. This is not. Okay, because this originally is Poisson. So originally should have the answer one. Therefore, when you want to make it become the normal distribution, again, you have to do some continuity correction first. So 30, 29, 30, 31, and 32. So for this example, they're talking about x equals to 30, which means that this is the area that they want you to find. Can you see the highlighted one? Okay, so when you want to do the continuity correction, what you have to do? You have to cover the area that you want to calculate. So if you look at the green color line, they are actually between 29.5 until 30.5. Okay, so from this part onwards, I want you to do it on your by yourself. Okay, from x change it becomes z, then try to find the probability, and the final answer that you should get is 0.0726. Okay, so I actually want to force you to make a simple revision for yourself on normal distribution table, since you are going to use it also in the exam later, right? Okay, so make sure that you are very familiar with the normal distribution table here. Okay, so for your information statistic too, the normal concept, normal distribution concept is very important. You need to know very well how to use all the table and everything for the normal distribution table. Okay, so this is what we have for part C. That's the answer. Right, so you will see that generally for this whole process, it is not very tough because the condition is very simple. That's the first thing, just that you need to make sure that you do the continuity correction correctly. Okay, so example 16, I hope that there's no problem. Okay, hopefully you can get an answer. Then I'll discuss some maybe application question here. Okay, let's have a look. For example, I don't want to discuss 17 with you. Wait, let me have a look. This is what we have. Oh, this is 18. 17 is what? This is 17. Okay, 17 I don't want to discuss with you. 18 I also don't want to discuss. I maybe discuss 19 with you. All right. Okay, so we have a look for example 19. Okay, so they are talking about the number of complaints received by the company has a Poisson distribution with mean 10 complaints per day. So the interval given is per day, right? So from here, you know it is Poisson distributed. Okay, so if you look at part number A, they want you to calculate the probability that there are 10 complaints received in a day. So for part 1, the time interval given is still the same like what they give you in the question. So that means X is number of complaints. Okay, and then X is Poisson distributed. What is the mean? The mean is 10. All right, so do I need to change this mean into the normal distribution or not? No need, because it is still less than 15, right? So they want you to calculate the probability that X equals to 10. So for this part, you just use Poisson, E negative lambda, lambda power 10 divided by 10 factorial. So you should get 0.125. Okay, so not necessarily every time you have to change Poisson become lambda, become normal one. It depends on the condition actually. All right. Okay, then if you proceed to part number 2, Okay, so they said at least 50 complaints in a week. All right, so original interval given is per day, and now they're asking for in a week. All right, so that means you have to change your mean. So as the mean, 1 day is 10 complaint, multiply with a week means 7 days, right? And eventually you have 70, mean 70 lah. So very obvious this mean is large enough, and therefore you can change become normal distribution, which is 70 and also 70. All right, so if you look at part B, they want to calculate the probability that at least 50 complain. So it will be X more than or equals to 50, right? At least 50. So X more than or equals to 50. And after that, you try to do the continuity correction, which is X more than 49.5. Again, you can use the method that I teach you just now, but now I'm not going to discuss it anymore here. So the value should be 49.5. After that, you can change it become Z, which is 49.5 minus 70 divided by square root C. All right, and from here, what do you get? You get Z greater than negative 2.450. Okay, and after that, you can also write as Z smaller than 2.450. They are the same area, right? And eventually, you get 0.9929. Okay, so this is what you should get. So you can see that the whole idea is quite simple actually. It is not very, very complicated if you know all the details of continuity correction, okay, and also how to standardize and how to use the table. Generally, it will be quite simple and straightforward. All right, okay, so next one, example 20, I want to skip it also because it is quite simple and straightforward also. Okay, we can have a look for example 21. Okay, so for example 21, what I suggest is again, you can pause the video first. You try out on your own first before you come back to the answer. Okay, because we try to modify the question a little bit so that we want to see whether students understand how the question asked or not and how they actually tackle the answer, tackle the question and answer, right, and get the answer. Okay, so let's have a look here. Receive email randomly constant average rate of 15 emails per hour. Okay, so the interval given is per hour lah. The lambda is 15. Okay, so first, they want you to find probability that he received more than 2 emails during a 20-minute period at work. All right, so interval given is per hour, which is 60 minutes. Okay, and now they're asking for 20-minute period only lah. So that means now you need to change the mean a little bit lah. Okay, so what is the, maybe I let X equals to the number of email. All right, so from here, X is Poisson distributed. In 1 hour, you have 15 emails, right, for the mean. Therefore, for 20 minutes, you have to divide it by 3. Because 1 hour is 60 minutes, right? So to convert it into 20 minutes, you need to divide it by 3. So mean also the same, 15 divided by 3, and therefore you have 5. Okay, so what they want to calculate, they want you to calculate the probability of X equals to 2, or sorry, more than 2 emails. So more than 2 email means greater than 2. All right, so which is 1 minus E negative lambda. First term is always the 1, second term is always the lambda. Then the third one, you have to include the 2, right? When you want to minus it, so lambda squared divided by 2 factorial. Okay, so if you continue from here, you will get 0.871. Okay, so I think this is quite easy lah, still. Okay, very, very straightforward question. All right, then next one, for part number B. Okay, let's have a look for part number B. So now they said he worked 8 hours long per day. So find the probability that he received fewer than 110 email per day on each of 2 working days. All right, so when you look at this question, it looks like they're talking about 2 working days, but actually they focus on per day first. Okay, for 1 day only, but this happened for both days, 2 working days. All right, then if let's say you want to know more about part C, you can have a look for part C first. Then again, Jerry's working day is 8 hours long. Find the probability that Jerry received fewer than 220 emails in 2 working days. I want you to see these two differences. The difference for these two questions. All right, so the wording, the sentence that they use in the question is very important actually. So you have to be very careful when you want to answer the question. All right, so for part B, they are focusing on the number of email received for 1 day only, but you are having 2 working days, right? Then now you consider for each of the day, okay, they want to have less than 110. But for part C, you are having 2 working days and they just want to have a total of less than 220 emails. The meaning is different. Okay, so how are you going to answer this kind of question? Maybe you can start now. Okay, so for part B, for 1 day, right, he works for 8 hours. Okay, so for part B, I'm going to look for the mean for 1 day only, 8 hours. So which is 15 times 8. And you get 120 per day. So to make you understand better, I write out the mean in a detailed way is 108, the 20 per day only. Yeah. Okay, so you look at this value, it is large enough, and therefore we can change it become normal distribution, which is 120 and then 120. Okay. All right, then next, what they want you to calculate, they want to calculate the probability for 1 day is less than 110. Okay, so this is for day 1. And after that, you're having day 2, 2 working days. So day 2 also the same. You are having x smaller than 110. Okay, so the number of calls received in 1 and day 2 are independent. Because for Poisson, right, all the number of occurrence appear individually. Okay, so therefore for day 1 and day 2, the number appear independently. Therefore, you can multiply them. You have to multiply them, not plus. And another option, another explanation is 2 working days is a complete case. So 1 day is not complete. Okay, so 2 working days only considered as a complete case. So to complete the case, you have to multiply, not plus. Okay, so it depends on how you look at it. Okay, so again, originally these are Poisson distributed. So you need to do continuity correction first before you can continue. So after you do the continuity correction should be 109.5. Okay, and after that you can change it become Z. Both values are the same, so I just always square it, alright? So Z 109.5 minus the mean divided by standard deviation. And this whole thing, this whole value, I just want to square it. Okay, and then if you didn't do any careless mistake here, you should get Z smaller than negative 0.959 and the whole thing squared. Then from the normal distribution table, you get 1 minus 0.832 and you square it and eventually you should get 0.0285 as your answer. Okay, all right, then let's continue straight away with part C and you can compare the steps between these two. All right, so now for part C. For part C, because they are talking about 2 working days, okay, so 2 working days, not on per day, but it is for 2 working days. Therefore, when you want to calculate the mean for Poisson distribution, it should be 15 times 16. Because 1 day is 8 hours, so both day, 2 working days will have 16 hours. So it should be 15 multiplied with 16 and you get 240. So this is for 2 days. Alright, so please take note on this. You can see the difference. Alright, so for part B, we calculate only for 1 day for now. Right, then now, what is the normal distribution that you have? Okay, so 240 and also 240. Okay, when they want to calculate the probability for less than 220, so again, you have to do the continuity correction, which is 219.5. After that, you change it become Z and everything, you will get 0.0929. Okay, so if you try to compare this step and this step, you will see that actually they look although a bit similar, okay, but actually when you want to calculate the probability, you still need to follow the interval given in the original question. So here they tell you that, okay, I want to focus on per day first, then after that I only combine them become 2 working days. Therefore, the mean here is per day only. All right, so for part C, you will see that they straight away want you to have less than 220 for 2 working days. So that means for the mean, when you calculate, you straight away multiply it with 16, which is 2 days. So you're having 240. So please make sure you know how to compare these two, and also please compare with the sentence that they are using. All right, so I hope that you have the idea how to solve this kind of question. Okay, so in statistics, the words, the sentence, and also the keywords, okay, all the phrases that they use in the question is very important. Okay, so you have to interpret it correctly. If not, very easily you'll get the answer wrong. Okay, all right, so this is what we have for our chapter 1. We already completed our chapter 1, but before we end this, I will give you the answer for the examples that I asked you to try out just now. All right, so example 17, the answer should be 0.0551. 17, very, very easy. 18 also very, very easy, 0.016. Okay, example 19 is the example that I discussed just now, right? Then example 20. Okay, so for example 20, part A, answer is 0.809. Part B is 0.9792. Okay, and also example 21. So you have to complete the steps to get the answer for part C in 21. All right, okay, so just make it as a practice for yourself, especially for those who already forget normal distribution one, make it as a revision, okay, for your AS stats. All right, go through with the table in detail, and then you try to see how you get all the answer correctly. All right, so if you cannot get an answer again, let me know. Please message me through Facebook inbox, then I will try to reply you when I'm free. Okay, so here we ended our very first chapter for statistics 2. Okay, so I hope that you have the idea on what are we doing now. All right, so for next video, we are going to straight away start with chapter 2 already. Okay, so chapter 2, mostly the whole topic is still about it is still talking about the normal distribution and Poisson. Okay, so we'll discuss all this in the next video.